next on hand, we have Teri Zgoda. So Teri was originally, she learned at RIT, Rochester Institute of Technology in New York, and went from there to Brigham and Women's Hospital in Boston, and she is now at phase 1 in Colorado. Somewhere in there, she also became perhaps the youngest first place winner in the Nikon Small World competition. So I have an idea of the quality of the work that she has done.
Hi, thank you for joining my presentation, Microscopy is Art. My name is Teresa Zgoda, but often I go by my nickname Teri. Today, I will be talking about my journey through microscopy and how I blended art and science to create beautiful and intelligent photographs. I've been lucky to have many opportunities where I could explore, develop, and perfect photomicrography. I'll take you from my first experience as a student in college, my exposure to numerous scientific processes during my postgraduate internship, to the microscopy studio assistant job at a research laboratory, and then to where I am now, talking about the photographs I've made at each step. The background photograph in this title slide is one of my favorites. One of my professors introduced me to crystal melts, dissolving substances such as urea or hippuric acid pellets in water or isopropyl alcohol, and then letting the liquid dissolve to watch crystals form. Using cross-polarization and the addition of a quartz wedge, further diffracted light to lead to some beautiful colors. So then for this image, I dissolved urea pellets in isopropyl alcohol and dropped the mixture onto a microscope slide. I then used a hot plate to quicken the evaporation process, watching the crystals form before my eyes. I placed the slide in the lab's cross-polarization microscope and inserted the quartz wedge to the desired color spectrum. The art, how pretty and unique these crystals are, the science behind it. They exhibit birefringence, which is an object's ability to refract or bend light so that it appears as a different color. This can help determine the properties of an object, what it is made out of, especially in mineral science. So a little bit about me before I go even more in depth with my work. I am a 2017 graduate from the Rochester Institute of Technology, where I received a Bachelor's of Science in Biomedical Photographic Communications. It's a mouthful of a major, I know, but in summary, I learned an array of scientific techniques that can be applied in a multitude of applications, such as forensics, surgical, and of course, my favorite, microscopy. My introduction into microscopy started my sophomore year with simple compound light microscopes. I started in confocal microscopy my junior year when I was recommended to do an independent study with RIT College of Sciences Laboratory. This turned into a job as a microscopy assistant, giving lessons and helping classes and students on how to use a microscope. My favorite thing to do when I first started using the microscopes was gathering plants and water from the fish tank nearby classroom and seeing what existed within. It blew my mind that all of these microorganisms existed in aquariums that I had no idea about. These little ones here, for example, are Vorticella. This discovery actually led to my capstone project, documenting the microorganisms I found in the fish tank and crafting it into a children's book called The Hidden World of the Aquarium. It was fun simplifying the science to the level a child could understand, and including artful photographs of the fish. A big milestone for me was placing into Nikon Small World competition. I started gaining a little notoriety, first with this tapeworm image that's made it around the internet, then with the turtle embryo that placed first in a competition a few years ago. After I graduated college, I had a summer internship with Zeiss Microscopy at a marine biological laboratory. I had access to some incredible subjects and microscopes during that time. I'm so grateful for the opportunity I had to work with everyone there. Here is where my fellow intern Teresa Kugler and I created that first place turtle embryo image. I will be going on in more detail on how we created this image later on. My third microscopy-related job was at the Neurotechnology Studio at Brigham and Women's Hospital. I worked with amazing people that introduced me to such high-end microscopes and allowed me to practice imaging on my own in my free time. I discovered tons of new things to image, how to overcome challenges in imaging them, and I learned so much more about how neuroscientists use the microscopes to aid their research. This image is a color-coded projection of some eyeshadow using a Zeiss 880 Uri-Scan confocal microscope. A color-coded projection is when the colors are assigned to different focal planes. Since the eyeshadow only fluoresced in one channel, it didn't look very interesting. So I chose to use a projection to add more interest and make it more eye-catching. Again, art and colors, but it also lends some more information to it, such as the red pieces are higher up than the purple. Now I work in support with Phase 1, out near Denver, Colorado. I mainly work with their high-resolution aerial camera systems, which is pretty much as far from microscopy as you can get, but I hope I'll be able to get back into that field sometime soon. This picture of a Rocky Stadium was taken last summer with one of our aerial camera systems at about 4,000 feet above ground level, but if you zoom in, you can even see that the pitcher is about to throw the ball, which I think is pretty amazing. I like trying to find the similarities between aerial photography and microscopy, such that we photograph in different wavelengths of light to see different spectrums, and also trying to compare landscapes to microscopic fields. Now I'd like to take you through my microscopy journey, starting with some of my very first images, and then working up to that most complex image, the multi-channel Z-stack tiled image of a turtle embryo. Here are a few images taken my sophomore year of college, experimenting with different techniques and subjects. On the top left is some pollen I gathered from a flower outside, photographed using dark field illumination, which illuminates the subject from specific angles rather than just directly underneath the subject, which is really good for imaging transparent subjects, because you get that nice black background and it's easier to see the structures within. Next to that is some nail polish. One of our assignments in the microscopy course I took was photographing makeup. It was wild to me that these everyday objects look so different up close. So then below that is some cross-polarized hair strands, and next to that is a reflected light image of some teeth. Reflected light was shining light from above rather than below to illuminate the subject. And then just a couple more of my favorites. The top left was food coloring mixed with water and alcohol. I think it looks like a little space alien holding up a force field above a planet. And below that is another crystal melt. And to the right is a snowflake. We would have a microscope that was outside in the shed and acclimated to temperature. So when it snowed, we were able to try to catch snowflakes, put them on a slide, and see what they look like underneath the microscope. And for this one, I put a colored gel on the light source called Reinberg illumination. That way you can get a pretty nice gradient in the background. Like I said before, I love being able to photograph ordinary objects in such a way that they look so vastly different. Like this very first image that I ever submitted to Nikon Small World. It's a reflected light image of a torn Polaroid picture. At that time, I was just gathering any object I could find to see what it looked like under a microscope, and I happened to have this old Polaroid with me that I didn't really care what the picture looked like. So then I ripped it up and placed it on a microscope. That simple curiosity gave me an Image of Distinction award in the 2015 competition. I entered because my professor suggested we do, and it was surreal to me to see my name among all these scientists and PhDs and doctorates. The following winter semester at RIT, I got the chance to do an independent study with the College of Sciences confocal microscope. I had no idea what confocal microscopy was until this study, and it was a whole new challenge for me. How can I get the best possible images with so many different parameters to work with? Confocal microscopy uses lasers of specific wavelengths of light to excite the samples. And there are many different parts that go into taking a simple image, such as the channel of light, the depth of the subject, what resolution you want it to be, and magnification of the image. So the higher the magnification, the less depth you get, the longer it would take to take a picture. It was fun for me, finding subjects that would fluoresce and balancing getting a good image in a decent amount of time. This study evolved into me getting a position as a microscopy lab assistant. In my free time, I went through the slides the lab manager had in the room to see what would fluoresce or what looked cool to me. This is how I ended up with my Aurelia photo on the left as an image of distinction in the Nikon Small World competition in 2016. And that terrifyingly fascinating photo of the tapeworm on the right landed me 4th place in the 2017 competition. Once I got 4th place, the competition got a little bit more serious for me. Before that, I was just entering for fun. I had these pictures, why not do something with them? Now, I tried to make the highest quality images I could. A little bit more about these images before I move on is that both of them are falsely colored, meaning that the colors they are right now do not accurately reflect what color of light they reflected. I would use 3 wavelengths, red, green, and blue, but I didn't like how that presented in the image, so I would flip through. This is a Leica SP5 confocal microscope. They had a couple presets. So I flipped through those to see what I thought looked cool. Even if the colors aren't accurate, changing them can help highlight some structures better than before, such as the tapeworm suckers, which are the parts that look like the eyes. These are just a couple more examples of the different color setups you could use, and this is of the tapeworm's teeth or hooks. Summer of 2017, I was lucky enough to get an internship at the Marine Biological Laboratory in Woodsville, Massachusetts, along with Teresa Kugler, another biomedical photography student a few years younger than me. I learned a lot more about microscopy there and got to experience what life in the lab was like. Once again, in my free time, I imaged whatever I can get my hands on. Most of what Teresa Kugler and I did was assist the numerous summer classes that the MBL offered, but sometimes we got to image alongside them as well. These are some of my absolutely favorite images from that summer. The embryology course had a unit where they took embryos and ran them through a process called diaphanization or skeletal prepping. When this experiment was over, some of the students left behind embryos. The professor didn't need them, so Teresa and I took the chance to make some more cool photographs. Some of the embryos, there were only one species of, so we took turns with who imaged what and shared the pictures, like the turtle embryo and the chicken embryo. So the diaphanization process requires skinning and eviscerating the embryos. The professor teaching the course was kind enough to lend us a chameleon embryo to work on ourselves. As you can see on the left, this is what the chameleon embryo looked like before this process. Next, they were put through a series of chemical washes to dissolve and clear soft tissue. Alizarin red dye was then used to stain the bone and Alcium blue for cartilage. You can see what it looked like before, imaged in bright field, and then 2-channel fluorescence. The red dye fluoresced in the red channel, highlighting the bone structure really well. The blue dye aimed to stain cartilage, but fluoresced well in the green wavelengths of light. So, how did we capture this image? How did we get this plain embryo to look like what you see on the right? My colleague Teresa Kugler had photographed the turtle, and I combined the final images. Some of the biggest challenges Teresa faced while photographing was the size and thickness of the embryo. She had to take 28 photos in the X and Y direction in order to obtain the full panorama of the turtle. During each of these locations, multiple photos had to be taken at different depths in the Z direction in order to get everything in focus, since the microscope could only focus on one small plane at a time. Luckily, the Zeiss stereo microscope used had an automatic Z-stack setting, so all we had to do was set the top and bottom of the focus field and let the program do the work. Now, on top of that, we had taken images in 3 different channels, red, green, and blue, like shown in the GIF on the left. The program automatically combined these 3 channels into one combined image. On the right, you could see the skeleton shows up red, while the cartilage is a combination of blue and green fluorescence. It took a lot of time and patience in order to get everything we needed to make this image. So after that, I took the files produced to stack and stitch them together. I used a software called Zareen Stacker to combine all of the images at different Z's into one totally focused image. An example of which is in the top GIF using the chameleon embryo. The image on the right shows how much of the embryo could be captured within one field of view. You could see that the nose is pretty sharp, but the neck gets out of focus pretty quickly. So then I'd have a screenshot below showcasing all of the 28 stacked images. And then I chose to use Photoshop to automatically stitch the stacked images together. There are many different programs that can do this, but I feel like it did a pretty good job. It found the edges and blended the images together fairly well. I then adjusted contrast, exposure, removed some dust and other artifacts, rotated it a little bit, made the background a little bit blacker, and that gave me the final image that you see today. And here are two more tiled images. These were fairly flat subjects, so no Z-stack was needed. Both were pre-made manufactured slides. The left is of a pinecone section, and the right, a leech section. These were taken with the Leica DMI-8 that had a motorized stage, so it moved the slide for me, so much less work than the embryo. Another way to work on my microscopy skills was to take video. I fell in love with ctenophores, or comb jellies, and enjoyed capturing their rainbow cilia. I submitted a video compilation of these creatures to Nikon Small World's in motion competition, and managed to get an honorable mention. And then another one of those classes had a section on looking at termite guts. There are millions of microorganisms that help digest what the termites eat, and it was amazing to get the opportunity to look at them. The microscope used for these had a time interval for photography, which kind of gives it more of a stop motion or time-lapse sort of feel, which I think looks pretty artistic. Here are some of the images I took while at BWH. A pollen slide, where you could see two structures that fluoresce strongly in different channels of light. In the center is a confocal image microscope of a tea leaf. I had no idea how strange these tea leaves would look using a confocal microscope. That was one of my favorite things to do, was just to see how bizarre the things look at really high magnification. Then the image on the right is a composite of multiple pieces of pollen with different colors applied, and at a singular or smaller focal plane, not Z-stack. This was one I was aiming for more of an artistic approach. I wasn't trying to get the subject all at once. I kind of just wanted it to look very abstract. But thank you so much for taking the time to tune in to my presentation. I hope I was able to inspire you to blend art with your science as well, and to see the beauty in your work. I am very grateful for the opportunities I have had to explore the microscopy world, and I'm so happy to have been invited to this symposium, and to still be included in the scientific community. You can find more of my photographs on my website, terizgoda.com, my Instagram @tazphoto, and you can find my children's book, Exploring the Microorganisms of an Aquarium, on amazon.com. Thank you.